Hello everyone, this is Yashveen from Exam Help Web here. Today I'm going to be solving Paper 2 Variant 3 October-November 2019 0580 Mathematics. Starting with question number 1, write down the temperature that is 7 degrees below -3. So we subtract -7 from -3, so that is -3 minus 7, which is equal to -10. To calculate the value of root of 256 to the power of 0.25 plus 4 into 8, and we simply put these values in the calculator and put parentheses around 4 and 8, and that gives us the value of 6. 3. Here's a list of numbers. From the list, write down a cube number, and that is 27 cube of 3. B, a prime number, which from this set is 47.
Question number 4. Find the highest common factor of 84 and 105. I'll start by writing factors of 84, and they are 2, 3, 4, 6, 7, 12, and then it goes on. Next, I'll mention the factors of 105, which are 3, 5, 7, and goes on. Now to get the HCF of both 84 and 105, I'll multiply only the prime factors which are common on both the lists. So here I see common prime factors are 3 and 7. I'll multiply them and get my HCF, which is 21 in this question.
Question number 5, write in standard form A 72,000, and that is going to be 7.2 into 10 to the power of 4. B 0.0018, and that is going to be 1.8 into 10 to the power of -3, since we are converting it from a value less than 1. 6. Expand and simplify x plus 3 into x plus 5. So we start by multiplying x with both of the species of this bracket, which is x squared plus 5x, and then we do the same process with 3, and that becomes 3x plus 15. So we have the result as x squared plus 8x plus 15. Question number 7. Find the gradient of the line that is perpendicular to the line 2y is equal to 3 plus 5x. So first off, we need to have the coefficient of y as 1 over here, and for that I'm going to divide the whole equation by 2. So that gives us y is equal to 3 by 2 plus 5 by 2x. And this over here is the gradient of our first line. So I'm going to denote it as m1. And in case you have two lines that are perpendicular, so the gradient 1 into gradient 2 gives the answer as -1. So that should mean our gradient 2 is supposed to be -1 divided by m1, which in our question is -1 divided by 5 over 2. And that is equal to -0.4. So here we have our gradient. Question number 8. When sine x to the power of 0 is equal to 0.36, find A, the acute angle x to the power of 0. So acute angle gives us a hint that this angle is supposed to be less than 90 degrees, and so x is supposed to be sine inverse of 0.36, which is 21.1 degrees. The obtuse angle x to the power of this, and this is that. So obtuse angle means this is supposed to be between 90 and 180 degrees, and we can get the answer from by subtracting 21.1 from 180 degrees. That should give us 158.9 degrees. 9. A cuboid measures 5 centimeters by 7 centimeters by 9.5 centimeters. Work out the surface area of this cuboid. Alright, so we've got 6 faces over here. Um, three with 3 sets of 2 identical faces. So that should mean, let's suppose 9.5 into 5 plus 5 into 7 plus 7 into 9.5, and I'm going to multiply the sum of all of these products with 2, since we have 2 faces of each of these figures, and that gives us 298 centimeters squares. Fn is the mean of 3 numbers, 391, n, n minus 1. Find the value of n. Okay, so we have the 3 numbers as 391 plus n minus 1. And we're going to divide it by 3 because we have 3 of them, which is equal to 5n. So I'll shift 3 over here. That should give us 391. N plus 1 is 2n. And since, alright, so I'll just subtract 1 from 391 over here. So that should give us 390 is equal to 5 3s are 15n. So 390 is equal to 15 minus 2, which is 13n. N is equal to 390 divided by 13, which is 30. 11. Factorize a 12x plus 15. So I'm going to take out the common factor here, which is 3. So we have 4x plus 5. B, xy minus 2x plus 3y minus 6. So as we can see over here, the common factor is x. So we have y minus 2 in the bracket. Similarly, we have the common factor here as 3. So I'll take 3 out of the bracket and write y minus 2. And since both of these brackets are the same, I'm going to write them once only. And then we have x plus 3 as the second bracket. 12. A is a point 21 and B is a point 94. Find the length of AB. So I'll use the distance formula over here, which is x square minus x2 minus x1 the whole square plus y2 minus y1 the whole square. And then we have the root of the answer. So here we have x2 minus x1, which should be equal to 2 minus 9 the whole square plus y2 minus y1 the whole square, which means 1 minus 4 the whole square. And this gives us the answer as 7.62. Question number 13. A straight line joins the point 3k and 6 and k negative 5. The line has a gradient 2. Find the value of k. Okay, so we have the formula of gradient as y2 minus y1 over x2 minus x1. So I'll keep negative 5, negative 6 divided by k minus 3k. And we have the gradient in the equation in the question as 2. So negative 5, negative 6 is equal to negative 11 divided by k minus 3k is negative 2k is equal to 2. So I'll shift 2k on the right side, and multiplying this gives us the answer as negative 11 is equal to negative 4k. So k is equal to negative 11 divided by negative 4, and that is equal to 2.75. 14. Find the nth term of each sequence A. Alright, so we have a sequence over here, and let's see what differences do we have over here. The numerators are the same. However, the denominators have the same difference of 2. 4 and 6, 2 and 4, 6 and 8, and 8 and 10. So we're gonna have to use the arithmetic sequence formula over here to calculate the n term, which is an plus n minus 1 times t. This is the formula, and we have the first term of the sequence as 2. I'm not going to consider the numerators since they remain the same, so we need the formula only for the denominators. So we have 2 plus n minus 1 times the difference, which is 2. So we have 2 plus 2n minus 2, and that gives us 2n remaining. And that should be equal to 1 over 2n. B. So again, here we have another sequence, and if you divide the second number with the previous one, each number with its previous one except for 1, you should get the answer as 5. So we have the ratio of all of them as 5, and so we're gonna use this tells us that this is a geometric sequence. I'm gonna use the formula a1 times r power n minus 1, and a1 over here is 1 into r, which is the ratio is 5 over here, into n minus 1. So 1 into 5 power n minus 1 is equal to 5 power n minus 1. You can also test this formula by substituting any value of n over here. Suppose if you put 5 over here, you get the answer as 625, which tells us that our formula is correct. Without using a calculator, work out 2 by 3 plus 1 by 4 into 2 by 3. Write down all the steps of your working and give your answer as a fraction in its simplest form. Alright, so I'll start by multiplying 1 by 4 into 2 by 3 plus, which is our rule. So we have 2 by 3 plus 1. So 1 into 2 is 2 over 4 into 3 is 12. Now again, I'm going to multiply this fraction with 12 and the second fraction with 3. That is the denominator of each other's fraction, and that gives me 24 plus 6 divided by 36, which is equal to 30 over 36, and simplifying gives me the answer as 5 by 6. Question number 16. 10 athletes compete in both the 100-meter race and the triple jump. Their results are shown in the scatter diagram. So we have a graph over here. A. One of the athletes jumps 15.12 meters in the triple jump. Write down his name. Write down his time for the 100-meter race. Right, so as we can see over here, the smallest unit over here is equal to 0.02, and that should mean 15.1 has the next value. Alright, so the next value 15.12 is just the next value after 15.1. So we have a point over here. This has been plotted at exactly the point which we are going to consider for this question, and once we drag this back to the y-axis, we get the value here as 12.88, and so we have the answer of A as 12.88. B. The values for two other athletes are shown in the table. On the scatter diagram, plot these points. So first point is 14.74 and 13.2. I'll get my scale over here. Right. So 14.74 is just 2 units ahead of 14.7, which is here on the x-axis, and 13.2. Alright, so this is going to be right around there. The second point is 15.2 on x and 12.76. Right. So 15.2 is over here, and 12.7, 12.72, 12.734, 12.76 is right over here. Yeah, that's it. See, on the scatter diagram, draw a line of best fit. So we simply need to draw a line which covers the greatest number of points plotted over here. This can be different for every one of us. It doesn't necessarily have to be the same. So I think I'll draw it this way, which covers 3 coordinates, 3 points, and here is my line of best fit. Right. B. The values for two other athletes are shown in the table. Distance in the triple jump and the time for a 100-meter race. Okay, so I'll have to draw this. Okay, so I've got my scale over here with the graph, and we need the value of distance as 14.74. So we have 14.7 over here, 14.72, and 14.74 over here. So I'm going to align my ruler along with the 14.74 mark. Right, and then we have 13.2. Right, so 13.2, here we have 13.2, and so I'll have to mark it here. This over here is gonna be the point. All right, Okay, and then we have the second point as 15.2. So we have 15.2 over here, and then we have 12.76. Let's see, we have 12.7 over here, and 76 is going to be halfway between 12.7 and 12.8. So I'll mark 15.2 over here, and then I'm gonna drag it back to 12.76, which is just 2 units below 12.8, and this gives us the point over here. Alright, so I have the other point over here. C. On the scatter diagram, draw a line for best fit. Alright, so line of best fit simply means the line with the most number of coordinates, and you can choose them. You don't have to necessarily draw the same line. And I think I'm gonna go with, yeah, these three coordinates. The question now, draw a straight line over here, and that's it. Here I have my line of best fit. D. What type of correlation is shown in the diagram? This is a negative correlation, since the gradient is of negative value. Question number 17. By shading the unwanted regions on the grid, draw and label the region R that satisfies the following inequalities. So we've got x greater than negative 3 and less than or equal to 3. So here I'm going to be drawing the line, a dotted line for x greater than negative 2. So this is my first line. And then we have the second line as x less than or equal to 3. And this is going to be a whole line, not a dotted one. Okay, so here I've got the second line. For the second inequality, I'm going to be drawing a table. So we have x and y, and I'm going to take the x coordinates as 0, 1, and 4 using the equation y is equal to x plus 3. So 0 plus 3 is 3, 1 plus 3 is 4, and 4 plus 3 is 7. So we have the coordinates as 0, 3, 1, 4, and 4, 7. So I have my first coordinate as 0 on x and 3 on y over here. The second one is 1 on x, 4 on y, which is here. The third one is 4 on x and 7 on y over here. Now I'll draw a line along all of my coordinates. Okay, so here's my line, and now I'm going to be shading the regions which are unwanted. So this is the unwanted region. And here we have region R. Question number 18a. M is equal to x is to x is an integer and which x is greater than or equal to 2 and less than 6. So we have the set m as 2, 3, 4, and 5. Find number of components of m. There are 4. 2. Write down a set n where n is a subset of m and n is not non-existent. So we can write any of the components of set M. I'm going to go with 2 and 4. P. In each Venn diagram, shade the required region. Okay, so here we have A union B complement. So everything which is not A union B is supposed to be shaded over here. So I'll shade the rest of the region. Alright, C intersection with D complement union with E. So I want it to be united with union with E over here, which would be all shaded, except that we only want the part of C which is not intercepting with D. So this is the region which is going to be shaded. The diagram shows the speed time diagram for 70 seconds of a car journey. A. Calculate the deceleration of the car during the first 20 seconds. So we have the final velocity as 10 over here, subtracting the initial velocity, which is 16, divided by the time, which is 20 over here. The answer is 0.3 meters per second square. B. Calculate the total distance traveled by the car during the 70 seconds. So here we have a trapezium, this one. I'm going to draw a dotted line over here. So figure 1 is a trapezium and the second figure is a rectangle. So the area under the graph, which is also equal to the distance, is going to be area of trapezium plus area of rectangle. And I'm going to start with the rectangle over here, which has the base as 50 into the height, which is 10. Adding the area of trapezium should be equal to half into sum of parallel sides. So we have the lengths of parallel sides over here as 10 and 16. 10 plus 16 multiplied by the difference between the parallel sides is 20. And adding the products gives us the answer as 760 meters, which is the distance traveled. Question number 20. T is inversely proportional to the square of x plus 1. So we have T inversely proportional to square of x plus 1. Alright, when x is 2 and t is 5. A, write t in terms of x. So we'll substitute the values of t and x over here. So t is 5. K is unknown. X plus 1 means 2 plus 1, which is 3. And 3 squared is 9. So we have k is equal to 5 into 9, which is equal to 45. So we have t as 45 divided by x plus 1 the whole square. D, when t is equal to 1.8, find the positive value of x. So we have 1.8 is equal to 45 over x plus 1 the whole square. We can shift x plus 1 from here to here, which should be equal to 1.8 into x plus 1 the whole square is equal to 45. And then when we shift 1.5 to the right hand side, this becomes 45 divided by 1.8, and that gives us 25. So x plus 1 the whole square is equal to 25. Now if we root 25 over here, so x plus 1 is equal to root of 25, which is 5. X is equal to 5 minus 1, and that gives us the answer of x as 4. Question number 21. A. Work out the inverse of the matrix -3, 10, 1, -5. So we have the formula as 1 over AD minus BC. AD is -3 into -15, which is -5, which is equal to 15, minus BC is equal to 10. So and then we have D minus B minus C and A. So we have the answer as 1 over 5, -5, -1, -10, and -3. B. Work out the value of x and the value of y in this matrix. So we have 1 and 5 multiplied by -4 and 2, giving us the answer as x. So -4 plus 10, which is the product of 5 and 2, should be equal to x. So x over here is equal to 6. And then we have 2y multiplied by -4 and 2, giving us the answer as 6. So we have 2 into -4, which is -8, plus 2y is equal to 6. So 2y is equal to 6 plus 8, which is 14, and y is equal to 14 by 2, which is equal to 7. Hello everyone, this is Yashwin from Exam Help Web here. Today I'm going to be completing paper 2 variant 3 October number 2019 0580 mathematics, starting with question number 22. A container is made from a cylinder and a cone, each of radius 5 cm. The height of the cylinder is 12 cm and the height of the cone is 4.8 cm. The cylinder is filled completely with water. The cylinder is turned upside down as shown below. Calculate the depth of the water. The volume of water over here and here is the same. That is, the volume of water occupied over here and over here is same. And since the shape is not changing, total volume of the shape over here and here should also be the same. And that also means, in turn, the volume left unoccupied over here is equal to the volume left unoccupied over here, and which should mean that the volume of unoccupied cone over here in the first diagram is equal to the volume of unoccupied cylinder in the second diagram. I mean this cylinder. So here I have the formula of volume of cone as 1 by 3 pi into radius, which is 5 squared, into height, which is 4.8 of the cone. And this should be equal to the volume of cylinder over here, and that is pi into r square, which is 5 square, into height, which is unknown. So height over here is equal to, when we calculate this gives us the answer as 40 pi divided by the answer over here is 25 pi is equal to 1.6. So we have the height over here as 1.6, and if we subtract this height from the total height, which is 12 plus 4.8, we can calculate the height d, or the distance d. So we have our answer as 12 plus 4.8 minus 1.6 gives us the answer as 15.2. Question number 23. The time t in minutes it takes each of 50 students to travel to school is recorded. The table shows the results. Okay, so we have time over here and frequency. A, write down the model class. So the class with the highest frequency over here is from 10 to 15. On the B, on the grid, complete the histogram to show the information in the table. Alright, so to draw a histogram, we need to find out the frequency density over here, which is equal to frequency divided by the range. So the frequency density over here is 7 divided by 10, which is equal to 0.7, and here we have it as 19 divided by the difference between 10 and 5 is 15, and that is 3.8. Again over here we have 16 divided by 5, and that is 3.2, and the last one is 8 divided by 20, which is 0.4. So we have our frequency densities as 3.8, 3.2, and 0.4. So we have the first bar being from time 10 to 15 minutes, and the height is going to be 3.8. So we have 3.8 over here, and then we have the height. And the second bar is from 15 to 20 with the height of 3.2. So I'll start by marking 3.2 over here. And then we have the length. That's it. And the third one is from 20 all the way to 40 with the height being only 0.4. And that's it. Thank you for watching. This is the end of the paper.